Hello engineers, welcome to another exciting tutorial. My name is Dele from DevOps and Cots. Today we shall be talking about Terraform, which is infrastructure as code. So in today's tutorial I'll be showing you how to store our state files remotely. Now when you work with Terraform on a local machine, you use Terraform to provision infrastructure in the cloud, but then your state files are stored locally. The TF state files are stored locally on your machine. Now the state files helps Terraform and helps us to ensure that our desired state, which is the state in our configuration, in our code, is the same as the actual state of our resources in the cloud. So you make sure that everything is, it keeps track of everything we're doing. So it keeps track, our state files keep track of all the resources we have provisioned. Now, but there's a problem, because when you have your state files stored locally on your device or your local machine, and what happens when you try and collaborate, like in the real world, in the workplace, with other engineers, developers, and everybody else? So we need to have our state files stored somewhere remotely, which is also safe and secure. So we need to have it stored safe, securely. We need to have it stored in kind of a version control system, so that if anything goes wrong, we can also revert to the previous version. We need to have, it needs to be scalable, so that as we grow, it automatically scale to accommodate the growth. Also, it needs to have some kind of lock-in mechanism to avoid corruption of the state files. For example, when one developer or an engineer is working with Terraform, working on the state file, you don't want anybody else to have access to this. So this normally we do it in Terraform, in AWS, we store our state files remotely in AWS in an S3 bucket, which is object storage, and then we use DynamoDB as a lock-in mechanism. Okay, so I'm going to show you first of all how we do this normally. That's run Terraform code, improve your infrastructure, and keep your state files locally in your machine. And then I will show you how to move this state file, how to move the state file to S3 remotely, so that people can collaborate on this state file. Okay, so sit back, relax, and I'll see you at the terminal.
Okay, so today we should be learning how to store our Terraform state for infrastructure in a remote backend. So we need to have an AWS account, a Terraform project. I've got one here for you already. We need Terraform installed on your local machine and AWS CLI installed and configured on your local machine. If you don't know how to configure an AWS CLI, you need to watch one of my videos. I put the link right there, and you can look in the description here. You would see the link to this video. So we'll talk about Terraform briefly, and Terraform State, because this is about Terraform State. In summary, you have what we call a desired state and current state. Terraform keeps, it keeps a state file, which keeps a record of every single resource, and that has been provisioned by our infrastructure. It does this really well, and it ensures that our desired state and current states are the same. So in summary, the desired state is the high-level definition of infrastructure, how it should be configured, while the current state is the actual observed state of the infrastructure as it exists in reality. So your configuration is the desired state, and the actual current state is what is already provisioned in AWS in this case. Okay. Now people wonder, why do we need to store in a remote backend? It helps collaboration, because when it's local, other developers, engineers can't access your local machine. Also, locking mechanism, it helps to maintain, it helps your code to stay uncorrupted in that when one person is working on it, it stays locked. When you finish, the lock is released and somebody else can. It helps to prevent corruption of your state file. It helps with data separation and consistency. It's also very secure, helps with secure storage, so you can have your remote backend, like an S3 encrypted, and also you can have some kind of AIM. You can control access to it and privileges to it. Versioning, very important. S3 allows version of your buckets. That way, if anything happens, anything goes wrong, you can revert to a previous version. It needs to be scalable, so it can accommodate growth, and also it should allow integration with CI/CD pipelines. So in this case, we're building our infrastructure. It's going to be a VPC, 2 public subnets, an internet gateway, route table, and routes. We shall create an EC2 instance on which we shall install components for our CI/CD pipeline. That will be Jenkins for our CI parts, SonarQube for code analysis and scanning, Docker, Terraform, kubectl, Git, and Maven to build our Java application. After that, we shall test this by trying to view Jenkins and SonarQube in the browser. We shall do this first using a local backend, because by default, Terraform uses a local backend to store its state files. But then later on, we shall destroy this and we shall upgrade and store state files remotely in an S3 bucket, and we shall lock this using a DynamoDB table. And then we shall apply our new configuration, create our infrastructure, and then we shall check again for SonarQube and Jenkins in the browser. Okay, so this is about this is to teach you how to how to use a remote backend for your state files. So now this is a diagram. This is the architecture for today. Excuse me. There, the developer writes the Terraform code, builds application. That's the VPC. You can see the public subnet 1 and 2. In subnet 1, we shall create our EC2 instance, and we shall use our user data script to install Jenkins on port 8080, default Jenkins port, and SonarQube on port 9000, because we shall be accessing this too from a browser later on. Okay, then we have the route tables, the internet gateway, all provisioned with Terraform. Now, to keep state of what we're doing, you can see also we have Terraform State there. I'm as an S3 bucket, so we store the state file. A TF state file is going to be in S3 bucket, and it will be locked with DynamoDB. So that's our setup on a high level. I hope this diagram helps to explain what we're doing today. Okay, so our infrastructure will be, initially, we shall use local backend to store our Terraform our state files, and then later on we shall update this and use a remote backend. Yes. So I hope you understand also that if you want to learn to draw, you need to use there's a website called draw.io. You can go there and it will help you to map out your infrastructure, okay, visually. Okay, now so let's begin with our infrastructure. We'll start with our VPC and networking. Yes, okay. I won't go through this that much because this is not about building a VPC. I think this is about our state files. So for the code, you can go to my GitHub and you can get the code to work along with the infrastructure. So it's just a VPC, 2 subnets in the public, 2 public subnets, internet gateway. You can see route tables. Here we shall use an elastic IP for when we create our server our EC2, so that we can still have the same IP address if we stop and start our instance. Okay, so this is the code for VPC and networking, route table, everything else, and the subnets. After that, we shall go and have a look. We shall see our EC2 instance. Okay, this is the variables we've set, and then we shall assign the values in a TFVARs, Terraform.tfvars. There they are. It's nice to work this way because this way you can reuse code. So you use variables rather than hard coding your values. Okay, the region is going to be US East 1. That is set in our Terraform TFVARs as well. Okay, now we're creating our server, which I'm using a data source. I'm using those filters to return the most recent AMI. For our key pair, which I'm using an existing key pair, which I already have my EC2 key pair. It's already in my AWS account. And then there, our instance, we call it Jenkins _ server. You can see the AMI is the one from the data source we already created above. Now the subnet, you can see, as I said earlier, is in a public subnet 1. We're only creating one instance, which we shall use to provision and install the dependencies and everything else we need for our CI/CD pipeline. So subnet ID is public subnet 1, you can see. Instance type T2 large, because we need to install a few things. If you just install a few, maybe one or two things, you could probably manage with a T2 micro, probably. Okay, so now this is our security group. For instance, my instance SG, and there we shall open up particular ports to allow our setup to work properly. So port 80 for HTTP web access, we have port 9000 for SonarQube, port 22 for SSH access, so we can have remote access via SSH. Also, and then Jenkins is port 8080, you can see that below there, for Jenkins, port 8080. Without this, we shall have problems connecting to these installations. Okay, and then for our egress, we have this all set up so that we can download patches or dependencies, anything else into our instance. So that's the main thing for our instance. Now you can see we mentioned the script, so we shall use a Jenkins.sh, a shell script to install our software while our instance is being created. So we're going to install the following automatically. That's Jenkins, which we need for our CI part of our pipeline. Git to run some Git commands. Install kubectl from Kubernetes. Which is install Maven so we can build our Java application for our pipeline. Install Docker, also to push images to Docker and also for our containers. SonarQube for scanning, we need to scan our, also for analysis, and Trivi to scan our images. So that's this will be installed during creation of our EC2 instance, the Jenkins _ server. Brilliant. So now we've done this, we shall begin to we shall initialize and apply our configuration. Now look on the left. You see when we initialize, you will see that a .terraform folder will be created. This happens when we initialize because Terraform will initialize our backend and download any plugins it needs to connect to our provider. So it will be a .terraform folder. Inside it will be everything it needs to connect. So it's begin to initialize there. So anytime you would see a .terraform folder pop up on the left, yes, so you can see it's initializing the backend. Right now it's local because local is default. Okay, and then it's beginning to install the provider plugins. Initialize and install. So this shouldn't take that long. Yes, you can see that's the .terraform directory. It's been created. Yes. So Terraform has been successfully initialized. Okay. So let's clear this. We can go to the next stage. Let's do a plan, and let's see what will be created. Now, when you plan, you would see what would happen. We're going to have a terraform.tf_state file created. This is what stores our Terraform state. Okay, as remember I said, the state file helps us to Terraform to track, our resources and make sure that our desired state is always in line with the current actual state. You can see there, Terraform TF_state has been created, although it will disappear after the plan because the plan is a dry run. We're not really creating anything with the plan, but it just shows you that it'll pop up and then disappear when it is gone off now. Okay, now it shows we're going to create I think about 15 plan 15 to add. Okay, so now let's do an apply. Terraform apply, and we shall use the auto approve option, so that we don't have to pause to type a yes to run our apply. Okay, so we should do Terraform apply minus auto minus approve. Dash auto dash approve. Yes. Or hyphen auto hyphen approve. Okay, and let's run this. So it will do the plan, and then it will begin to create our resources. Okay, so you can see our tf_state file is there. Yes, I remember, as I told you, the tf_state is there. It will make sure that our desired states equals our current states. Okay, as I say, Terraform is idempotent, which means you can run the same configuration over and over again, and it will keep doing the same thing, and when there are any changes, it will update the changes, but it will not recreate any objects that have been created correctly. It's a very smart platform. Okay, so now it's being created. I can see the subnets, VPC, security groups. It's being created. When it's created, we shall check to see if our Jenkins CI is up, and also we'll also check our SonarQube if it's up. So because remember, these were installed automatically using a data script, which was set in a user data script in the instance. Yes, apply complete. Resources 15 added, changed 0, destroyed 0. Okay, so we have successfully, I hope, run this. Now we shall go to the browser. We shall get the public IP of our server. Okay, first of all, let's look in the state file. This is what the state file looks like. It has all the information about our resources we have created, all the information that Terraform needs. Okay, now here we are. Let's check our instance. It's running. Jenkins _ server, remember, it's what it was called. Yes, so let's get the public IP and go to the browser and see if SonarQube and Jenkins CLI have been successfully created. So let's go IP and then Jenkins port 8080:8080. Yes, success. Jenkins has been properly configured. Now we'll check again with SonarQube. SonarQube is port 9000 by default, which is what we set. So we shall go also public IP :9000, and let's see if SonarQube installation was successful. Remember, Jenkins and SonarQube are needed for our CI/CD pipeline. :9000. Let's go. Sorry about that. Do this properly. The public IP, paste that there. : 9,000, yes. Let's go. Okay, yes. So that cube was fine as well. So log it there. So ladies and gentlemen, we have done the first part using a local backend. A local backend. We are going to destroy our infrastructure and then reconfigure, recreate using and instruct Terraform to use a remote backend instead. An S3 bucket with DynamoDB. Okay, so let's destroy our resources now. So Terraform destroy, auto approve, and it's being destroyed. It shouldn't take too long. We're destroying the 15 resources we created earlier. It's been destroyed. Yes. Okay. So you can see on the left, Terraform State, there's a backup folder now. It backs it up when you destroy. Okay, so now let's refresh SonarQube. It should tell us, it should time out now because we have destroyed our infrastructure. Yes, can be reached, error, correction timeout. Jenkins should do the same too. It should time out because we have destroyed our infrastructure. Yes, timed out. So everything's been destroyed successfully. Yes, now let's see S3. We should have nothing here because we haven't created an S3 bucket yet. Let's go to the buckets. There should be nothing there. We shall do this with Terraform. Okay, you don't have any buckets as expected. Yes, thank you. Now let's look at DynamoDB. DynamoDB, which we use for our table locking. Let's click on the tables. Yes, you have no tables in this account, in this AWS region. Yes, as expected. Yes. So we shall now go to our configuration, create a new folder, use this to provision, our bucket and table, DynamoDB table, and then we shall instruct Terraform to use this for the new configuration. Okay, so let's go to this, let's create a new directory. Okay, new directory, we can call it something like maybe backend, so make directory backend. This will make a new folder, a directory, and this folder we shall create 4 files. For our provider, as usual, we need a provider to run Terraform. A provider, we have AWS. We shall do our variables, a folder for our infrastructure, our creation, the main folder. It could be main.tf or we could call it backend.tf. And then we shall have a terraform.tf vars to set the values for our variables. It's nice to use tf vars because then it allows us to reuse our code, because all you have to do is just change the values in the tf vars and you can run different configurations using the same code base. Okay, so yes, terraform.tf vars is the last one, where we shall assign values to our variables in variables.tf. Okay. Okay, so let's set our provider. First of all, our provider is AWS. That will be, hold on please. So we put this in a new folder called backend, so that we can run this without running the other files for our infrastructure. We want to create the backend first before we create our infrastructure. Okay, so region is going to be US-1, the same region as our backend, as our infrastructure. It will be the same region. Okay, so let's do the backend now. That's the files. We shall create 4 resources: S3 buckets, DynamoDB table, we shall create a resource to have our buckets versioned and also to encrypt, to have server-side encryption by default for our buckets. And of course, the bucket name and the table name are variables, which we set in a Terraform.tf. So, yes, the first resource, if you create S3 buckets, we shall do that. The next one is versioning. You can see we shall version our bucket, enable versioning. Then we shall enable server-side encryption. Yes. And then we shall create a DynamoDB table. So 4 resources to be created at this time to prepare our backend. And remember, the hash key is lock ID. It has to be lock ID to be able to use it as lock. Okay, so that's done. And then in our Terraform.tf vars, we have assigned values for our variables. So they have assigned values for the S3 bucket name and the DynamoDB table name. So the variables, bucket name, and table name. And if we go to the Terraform TF vars, you would see the values we have assigned. Okay, so everything's looking good. To create our backend, set 4 resources, buckets, versioning, encryption by default, server-side encryption, and the DynamoDB table is what we need to set up our remote backend in this case. Okay, and then so this is our TF-vars file, and you can see our bucket name is going to be DevOps and COTS remote backend. Sorry, yes, and the table name will be DevOps and COTS Terraform login. Remember that? Remote backend and Terraform login. So we shall go to our, okay, let's run this first. We shall create the backend first, and then later on we shall come back to our configuration and instruct our Terraform to use this backend when creating our infrastructure next. Okay, so let's begin to initialize. We shall run Terraform init. We shall plan and we shall apply this backend. And then we shall later instruct our configuration file structure to use this backend to store its state file. Okay, so let us proceed. So let's do Terraform init. Let's initialize our configuration, initialize the backend, initialize provider plugins. Yes. Plugins, AWS plugins have been initialized. You can see our .terraform file has popped up on the left as expected. It shouldn't take long. I'll leave it with that. Yes, done. So we have initialized our configuration, the backend configuration, just initialized. Let's clear this and let's do a plan. We're going to have 4 resources. Remember I told you 4 resources, we saw that. Create bucket, create DynamoDB, version the buckets, and enable server-side encryption for buckets. 4 resources are going to be created. You can see our TF state in action there on the left. State files play an important part. In fact, they are the brain of Terraform configuration. So plan 4, you can see, plan 4 to add. Okay, so let's clear this and begin. Apply, auto approve option. Let's auto approve and it will plan and then begin to create our backend. Okay, we're getting towards the end of this. The first stage here we're doing here is create the backend, and then we shall later next it instruct our configuration to use this backend when we're creating our infrastructure. Apply complete. Okay, 4 added. So we shall go to AWS console just to confirm that they've been created. Remember, remote backend and Terraform locking. That's what we called those 2 resources, which we need to effect our remote backend. So let's take a trip to AWS console. Let's check now and see if indeed they have been created. We'll start. Let's check in DynamoDB. Let's take a tip. Remember we called it Terraform locking. DevOps on caught Terraform locking. Let's see if, yeah, there it is, being created there, you see. Remarkable. That's the power of Terraform. Write the code, run apply, and it does its magic. So DevOps on caught Terraform locking, that's created. Okay, now let's check S3. It was called remote backend. DevOps on caught remote backend. That's the S3 bucket name. Yes, there it is. DevOps on caught remote backend. So we have created our bucket and table, DB table, DynamoDB table. So now we can go back to our configuration and edit this to now use the bucket and the table for its Terraform as a state for its state files. Okay, as its backend, remote backend. So let's go back to our provider. In our main configuration, we need to go to provider, and then a Terraform block which I put in as the backend S3. Now you can see we've set the bucket name to the one we've created. We set the table name Dynamo underscore table name to the table we created. Okay. Encrypt true, region US East 1, which we're working on, and then the key. That's just the path to where you want your state files to be. Okay. So this is all we need to tell our configuration, and it will use this as its to store as a backend, remote backend. Without this block, it will use the local backend, local machine. Okay, so let's clear this and let's initialize again. We run Terraform init. Okay, so now we're going to build architecture all over again, but this time state will be stored in a remote backend. Okay. So let's go to a folder where we have our configuration and Terraform init. Let's initialize. Let us initialize. Okay. So it says successfully configured the backend. You can see that. So now Terraform knows that it's meant to use the backend for its state files. So it's going to change to that. It says there, successfully configured the backend S3. Terraform will automatically use this backend unless the backend configuration changes. So let's save this just for in case anything goes wrong here. It's just for my to save my configuration files, my files. Okay, and now let's on the plan. Let's apply straight away. Why not? Auto approve. Okay. And now you see it's acquired the state lock because there's state locking now. So acquire state lock, and when it finishes, it will release the state lock. During that time, nobody else can work with this config and work with the configuration. Okay, that's the plan. Now let's go start building. Okay, now it's building it's building now. Now start building. So right now it is using the remote backend. No more local. We have upgraded. Now teams can work together. We can collaborate because our state file is no more stored locally. Apply complete. So now let's check to make sure our code is still functioning. We shall check our Jenkins CI on the browser. Also check our SonarQube, which is required for our CI/CD setup. Okay, so let's get the public IP, and then public IP colon port number will take us to Jenkins SonarQube. Okay, SonarQube is 880, Jenkins is it's 9000, Jenkins 880. So Jenkins first. Run Jenkins. Yes, that's still working, so we're fine. We have not broken anything. Next, again, it will be colon 9000, public IP colon 9000. Yep, Sonar is there as well. So SonarQube is there as well. So nothing has been broken, and we have successfully moved our state file from local to remote backend. So we're storing in S3 buckets, and we're locking with DynamoDB. So ladies and gentlemen, now you know how to how to run your configuration. You know how to use a local backend, and you know how to upgrade and how to use a remote backend. Okay, pretty straightforward. Thank you for watching another tutorial. My name is Dilly from DevOps Uncut. Please don't forget to share, like, and subscribe. This will help me make more videos. This will encourage me to make more videos. Okay, so please don't forget. Thank you very much, and I'll see you again with another interesting